Good morning, students. So we'll move on to the next topic, that is epsilon NFA. Fine. So in previous session, we discussed what exactly NFA stands for. Fine. And we also discussed like how to convert NFA into DFA. Right. So we'll go for epsilon NFA. Okay, non-deterministic finite automata or as non-deterministic finite state machine with epsilon transition. Okay, what do you mean by epsilon? Like epsilon states you don't have any kind of input. Okay, so if NFA is possible to make a move from one state to another state without having any input also, that we are calling it as epsilon NFA. Okay, so we'll go through this. So it's very simple, but very important topic will be conversion of epsilon NFA into DFA. Exactly. We are using a property of E-closure. Fine. So we will discuss in today's session. Okay, so first we will discuss what exactly epsilon NFA stand for, how it looks like. Okay, then what is the definition of NFA, sorry, epsilon NFA. Then later we'll solve 2 to 3 problems over NFA problem, then we will go for a conversion. Clear? Okay. So in this session, okay, let us see the extended model of NFA called epsilon NFA. An NFA with 0 or more epsilon transition is called an epsilon NFA. Fine, please see this. Now let us see what is an epsilon transition. Okay, we go to the definition. A transition with an empty input string is called an epsilon transition. Okay, it will be read as epsilon transition. Yeah. Okay. Like if you are not having any kind of input like a comma b or a 0 comma 1 or any other input alphabets also, okay, your NFA will be in a possible position that okay, it can make a move from one state to another. Okay, if that is the case, we are calling it as epsilon NFA. Okay, fine. That is, if there is a transition from one state to another state without any input, that is no input, implies empty string denoted by epsilon, or else we are calling it as epsilon transition. For example, consider the finite automata shown below over here. Okay, you can observe Q0, Q1, Q2 are the 3 different states. Q0 will be the start state, Q2 will be the final state. So we can easily identify that we got total 3 different input alphabet like A, comma B, comma C, right? ABC are the total alphabets. Okay, and observe it carefully. From Q0 to Q1, we got a transition for A and also for epsilon, right? Then from Q0 to Q2, also we are having a direct arc, okay, which is labeled as B comma epsilon. Okay, and also we got from Q1 to Q2 with B comma epsilon. Okay, remember here alphabets will be A comma B comma C. Okay, don't feel that we are having a transition for epsilon, so the sigma will be also equal to epsilon. Wrong. Remember, okay, epsilon is just an indication that without any input also it will go for next step. Here, epsilon is not an input. Remember, it is not an input alphabet. Okay, a common mistake what student used to do or your seniors used to do is, okay, while writing the epsilon NFA version, okay, while defining the definition, sigma will be equal to, they used to write sigma, epsilon, comma A, comma B. Okay, that is totally wrong. Remember, epsilon cannot be an input alphabet. Okay, we are not having any input alphabet for that particular transition. Because of that, we are naming it as epsilon. That's it. Epsilon is not an input alphabet. I repeat. Clear? Okay. From above finite automata, we can observe the following points. Okay. In the above finite automata, we have more than 2 transitions. Okay. From state Q0 with input symbol A. Yes. For Q0, we are having one for self loop we have, right? See, this is what the self loop. Okay. And also from Q0 on receiving A, we are going for Q1 exactly. Okay. Means single state. For a single alphabet, there are multiple transitions. So obviously, this will be epsilon. Sorry, obviously it will be NFA exactly, right? And also we can observe that from Q0 to Q1, Q0 to Q2, Q1 to Q2. Okay, see, along with ABC transition, we are having for epsilon also. So this easily we can identify that yes, this is a NFA which enables the transition of epsilon. Okay, so we are naming it as what? Epsilon. Okay, so here we got some note. If 0 or more epsilon transitions are present in a finite automata, then it is called as NFA, epsilon NFA. Okay, if there is a epsilon transition, then NFA makes transition without receiving any input symbol. Remember this. Okay, we are not having any input symbol, so this NFA is having a potential to move from start state to final state. See here, Q0 to Q1, or else directly Q0 to Q2 also it is possible, right? When you are not having any kind of input. If sigma is equal to null, okay, you don't have any input. This NFA is possible, or it is having a potential to travel from Q0 to Q2, final state, without having any input. Okay, so these are all it depends on some situation. Okay, while designing the logic and all, fine. Sometimes such kind of situation will be arise. Okay, so for that purpose, we are using this kind of epsilon. Okay. Before worrying about the definition, let us consider the following picture representation of epsilon in a phase. The same example we got. Okay, so here we are trying to represent what are the input alphabets available, then what are the different states we got, okay, and what exactly the transition function available we have. Okay, so when it comes for the states, okay, Q will be equal to total 3 states, Q0, Q1, Q2, right? Total 3 states we got. Then later the input alphabets will be, oh sorry, so here they made a small mistake, like the input alphabets, they mentioned like A comma B itself. Actually, it should be A comma B comma C. I think they forgot to mention the transition of Q2 exactly. Okay, so here, just let me read this, what they are trying to explain over here. Input alphabet, each edge is labeled with A or B and representing the input alphabet, which can be denoted as, okay, so here comma C is exactly, okay, comma C, because for Q2 we are having this C. Okay, I think they forgot. Okay, fine. We can edit it, no problem. Then the transition, okay, fine. We'll see what are the different transition functions available, or as the gesture of the transition function. It is same as usual what we have for the DFA and NFA, same delta of Qi comma A will be equal to Q. Okay, so Qi comma A will be equal to sometimes Qj comma Qk also. Okay, multiple number of states may be available. See here on receiving A, observe it carefully. Receiving A, Q0 will be having, if I write like delta of Q0 on receiving A will be equal to what? Will be equal to one value will be Q0 and second value will be Q1, obviously, right? Because here one transition for Q0 and another transition for Q1 is right? So like that, we got for epsilon transition also. Epsilon transition also. Just observe it carefully. What we have got for epsilon transition. Like delta of Qi comma sigma. Okay, so not sigma, epsilon. Okay, will be equal to Qj. Will be equal to Qj. Fine. Okay, will be equal to Qj. So how to write the epsilon transition? Delta of Qi comma epsilon will be equal to Qj. Fine. So that is what how we are going to write the transition for epsilon example. Okay. Same. We are not having any kind of a different transitions available over here. Then we'll go for the transition table. You can easily observe like Q0 on receiving A, it will be going for Q1 comma Q2. The representation, the last two column we are having, the delta function if you are using, then that can be represented in such a way. Okay, fine. Then later for B, Q0 on receiving B, it is going for Q2, so that we are writing like this. Then later, Q0 on C, okay, like Q0 is not having any kind of a transition for C exactly, that's why null we are. How it can be represented using delta function like this. Remember, okay. Then later, although epsilon is not an input alphabet, okay, which is not, which is never inside the sigma exactly, okay, but still we need to represent the transition function for epsilon also, because in our transition diagram it is already represented. Okay, so Q0 on receiving epsilon. So according to the previous picture, observe it. Okay, description of NFA. Okay, Q0 on receiving epsilon, it will be going for Q1. Okay, same thing we are writing Q0 on epsilon will be going for Q1 exactly. Okay, so delta of Q0 comma epsilon will be equal to Q1. Like this, we need to write it. Yeah. Okay. So this is what the exact definition of the epsilon NFA. It is also consisting of total 5 tuples. One will be state, second will be the sigma, and third will be the delta function. Okay, along with the start state and the final state. Okay. Remember, whenever we are performing a transition, remember this. Okay, when we are performing the transition, we are trying for the different alphabets, right? A comma B, C. Okay, we are trying to find the transition for Q0 on receiving A, Q0 on receiving B, and Q0 on receiving C exactly. Like that, we need to check for epsilon. Okay, we need to check for epsilon. That's why we can observe here. Okay, delta of Q. Q means the states. Cross product of what? sigma union epsilon we are writing. Sigma union epsilon means sigma stands for what? A comma b comma c. According to this particular representation, okay, sigma will be equal to A, B, C exactly. Along with that, we need to have a transition function for epsilon also. That's why what we are doing, we are performing a union operation between sigma and epsilon. Okay, then your cross product of Q will be what? With A, then later B, later C, and also with the epsilon. So 2 to the power of Q, that is what the power set means the possible, the return value, whatever we are going to get after the computation of the delta function. Okay, so that we are representing. So you can observe here. So Q to the power of Q means, okay, so these are the possible outcome we can get. Sometimes null we can get, sometimes Q we can get. Return of this. See, return of this, okay, maybe from this particular power set. Okay. Now, the very important concept, we call it as E-closure. Okay, very simple. We need to find the E-closure for each and every state. Okay, what does this E-closure stand for? We'll see this definition. The E-closure of Q denoted by E close within a bracket Q exactly is the set of all states which are reachable from Q on epsilon transition only. Okay, example, like if you are having one particular state, okay, so from that particular state to next state, if there is an epsilon transition, then that next state is reachable. We are considering it as next state is reachable for the present state example. Then now, if that second state, see, I'm going to take it as Q naught, okay, is having the epsilon transition. Okay, fine. I will explain this figure itself. Okay, before that, I would like to tell two more points. Okay, wait for a second. Okay, so we'll discuss the two more points first. Okay, then I will come back to this figure. Okay, so now the E-closure, how we are going to write E-close of Q is we are going to write. Okay, so for the epsilon transition, whatever we are having, that only we need to consider. It is recursively defined using recursion as shown below. Okay, the state Q is in E-closure of Q, that is E-closure of Q will be equal to Q. Remember, whenever you are trying to find the E-closure of any particular state, E-closure means the reachability we are going to check. Okay, like from particular state, we are going to check it for Q. Okay, in this particular condition, observe it. In this particular condition, we are checking for what Q exactly. Now we are trying to see from Q how many different states are reachable. Okay, how many different states are reachable? See, if you are in Q, Q is already reachable, right? So E-closure of one particular state will be equal to itself. Okay, along with that, if there is an epsilon transition for any other state, then we are going for what? Then we are going for mentioning those states also. Okay, in that we are having one particular state and you are trying to find the E-closure of that, and we are not having any kind of epsilon transition from that particular state to any other particular state. Yeah, then E-closure of that particular state will be equal to same. Yeah, so when we solve the problem, you'll be having better knowledge about this. Okay, then later, second very important point, if E-closure of Q contains P, okay, means we are feeling that we are taking the example of like Q is reachable for P exactly, means there is an epsilon transition between Q and P exactly, and if there is a transition from state P to state R labeled epsilon, okay, it is like Q to P, we are having epsilon transition. P to R, also we are having epsilon transition. Then state R is also reachable in E-closure of Q. Remember, okay, see, three states if you are having, all are having epsilon transition between, then all are reachable. Remember this. Okay, when you solve the problem, easily you can understand. So here we got the example, same example I'm going to consider. For example, the epsilon closure, or as E-closure we are calling it as, of Q for each Q which belongs to Q is shown below. Okay, means whatever we are going to get the return value of this particular E-closure, okay, always it belongs to Q exactly. Let's see this. Yes, obviously, because Q stands for the state. Okay, so if this is what the figure, okay, we got the state Q naught, Q1 and Q2 are reachable from Q naught without giving any input. Okay, see, if you are trying to find the E-closure of Q naught, observe it carefully, E-closure of Q naught will be equal to Q naught, Q1, Q2. Q naught, Q1, Q2. Okay, so now observe it, Q naught to Q1. Okay, what we have? Epsilon transition we are having. So Q1 is reachable. Then Q0 to Q1 epsilon transition we have. Q1 to Q2 also we have epsilon transition. And also we are having one more transition from Q0 to Q2 with epsilon effect. So we can easily write like E closure of Q0 will be equal to Q0, Q1, Q2. You may ask like why we are writing or why we are including Q0. Remember this point. E closure of any particular state will be equal to first itself. Then later, if epsilon transitions are available, then it will. Okay. Now let me take one this example. See here, if we don't have this particular epsilon transition, here also if we are not having this epsilon transition, then E closure will be equal to what? E closure will be equal to E closure will be equal to E closure of Q0 will be equal to Q0 comma Q1. Here Q0 comma Q1 it will, because see here Q0 to Q1 epsilon transition we have, but Q1 to Q2 we don't have any epsilon transition. Likewise Q0 to Q2 also we don't have an epsilon transition. So for E closure of Q0, Q0 is reachable and Q1 is reachable. Yeah, super easy. Okay, so now after understanding the E closure property, we'll go for the first problem. Obtain an epsilon NFA which accepts strings consisting of 0 or more A's followed by 0 or more B's followed by 0 or more C's exactly. Okay, it is stating like 0 or more, all the conditions, observe it, number of A's, 0 or more, number of B's, 0 or more, number of C's, 0 or more. Okay, if all three become 0, what you will be left with? Epsilon, right? Then if you are left with 0 number of A's, 0 number of B's and 0 number of C's, then also your NFA must accept it. Then what we need to do? We need to design epsilon. How? We'll see this. Okay, so now the epsilon NFA that accepts strings of 0 or more A's, 0 or more B's and C's can be represented as shown below. See, three states we are consuming over here, all are having self-loop because any number of A's we can accept it. Okay, but it is given that 0 or more A's should be followed by 0 or more should be followed by 0 or more C's. So there should be a transition from state Q0 to Q1 on epsilon and between Q1 to Q2 also. Okay, so because of that, what we are writing, okay, see, self-loop for Q0, self-loop for Q1, self-loop for Q2, okay, and in between, epsilon we are writing. Okay, if all three become 0, 0 number of A's followed by 0 number of B's followed by 0 number of C's, also your NFA is possible or your NFA is in a position to accept. Okay, so same thing if you are writing it for the definition of epsilon NFA, how we are going to write. See, this is what a NFA with epsilon transition, that's it. How many states? Q will be equal to Q0, Q1, Q2. Then sigma will be equal to A, B, C. Yes, A, B, C. Don't include epsilon. Okay, then Q0 is the start state. Q0 is the start state, obviously, and Q is the, sorry, your Q2 is the final state. Okay, then the transition function, how we can write over here, observe it. Q0 on receiving A, Q0 on receiving B null, on receiving C null. On receiving epsilon, it will be going to Q, like this we need to write. Okay, so now, one more question. Obtain an NFA to accept language L. Okay, so W, where W belongs to A, B whole star, and W is made up of an optional A followed by double A. Observe it carefully. Optional A followed by double A. Okay, means there is one place, okay, where A may occur or may not occur. Okay, but later there are two places where A must occur over there. Okay, how we can design? See, there is a gesture of epsilon NFA available over here. Fine. So here minimum string is what? Minimum string is what? 2 exactly. Right? Okay. 2 number of minimum string we are having. Along with that, an optional A we are having. Right? To handle this, we need 2 states. For handle this, we need 3 states exactly. Right? So 2 plus 3 total 5. Total 4 states we need. Okay, so for handling this 2 we need, for handling this 2 we need. So 2 plus 2, 4 is there. Okay, so now starting from Q0, so here we are providing the option for A. Okay, so epsilon comma A we are writing. Okay, then it will be coming for Q1. Then continuous double A we are writing. First A and second A. Finally it will be accepted. But here you can also observe the Condition for B. Remember, B whole star we are having. This indicates 0 or more. This indicates 0 or more. Remember. Okay. So for B, what we do? Okay. So self loop we are providing. Self loop for Q3 example. Self loop for Q3. Okay. Then optional A followed by double A followed by any number of B's can be accepted. For the same, we are having this particular transition table, and these are the transition uh, definition we are having for epsilon. So these are the two problems over epsilon NFA students. Okay, so it's very easy. In next video, we will go through the conversion of epsilon NFA into PF exam. Thank you, students.